Bismillahirrahmanirrahim. Assalamu alaikum. Today is our first lecture, and it is actually the introductory lecture about the DSP. What is DSP? DSP is actually the abbreviation of three words, which are the digital signal processing. Digital is actually the finite set of values to represent real world objects. Its values are always, the signals are always in form of zeros and ones in the binary form. The next letter is the signal. Signals are actually the variations if any physical quantity which is changing with respect to any variable, then it will be called as a signal is actually any varying thing, and the signals come from the sensors. Where there is a change, it is sensed through the sensors, and then the output of that sensor is actually called a signal. Then processing is actually the transformation via some algorithm or techniques that converge from one form to modified version of the original signal to get our desired value or our desired signal. So DSP collectively is actually concerned with three things, which are the representation, transformation, and the manipulation of a signal. Its examples are the enhancement of visual images, speech recognition, and regeneration. Its applications in telecom field are the multiplexing, compression, and the echo control. Now we'll consider we'll look we'll go through the two examples, which are actually the resolution of three images, and we have to here we have three images, each with the resolution 300 cross 400, and we have to transmit all the three images through a channel whose bandwidth is actually 1 kilobyte per second. The bandwidth 1 kilobyte per second means that in 1 second we can transmit 1 kilobyte or 1 kilopixel data. Okay, here the first image will take 300 cross 400 is equals to 120k 120. The bandwidth of the first image is 120 kilo pixels. Same for the second and the third image. So this means that it will take 120 seconds to transmit 120 kilopixels data from source to the destination. So by adding all the three values, we'll get 360 seconds to transmit the three images. It will take 360 seconds. Now we want to optimize our system by using some DSP techniques. So we can see that the three images are the same except this portion and this portion. So we'll transmit only this image with changing this part of the second image and this part of the third image. So by taking the resolution of these parts, the resolution of this part is actually where it is, it's a 150 cross 100, and the resolution for this part it's 150 cross 100. So their corresponding will get 115k. So it will take 15 seconds to transmit the second image as well as the third image. By adding three times, we'll get 150 seconds. Now you can see first initially we were transmitting our data in 360 seconds, and now we have transmitted it into 150 seconds by simply applying the DSP techniques. The second example is about the search, the linear search and the binary search. When we are given with some data, either it is random data or some kind of sorted data, then we apply two types of methods to search some number or some digit from our data. For example, in this example, we have this random data and we have to find some number, for example 45, from this data. So to find 45, we'll do iterations. Of course, we'll do iterations to find 45. We'll first go to this, then this. On the ninth iteration, we'll get 45. So our cursor will stop at the ninth iteration. So in the same way, to find the 94 from this data, we will go through the 13 iterations. To find the number 4, we'll go through the 1 2 3 4 iterations. And to find the number 6, for example, we'll go through the first, we'll find the number 6 at our first iteration. So it is the best case in this example and the worst case is 65. How it is the worst case? As the cursor will keep on doing iterations and it will not find 65 because 65 do not exist in this data. So it will be the worst case and the system will have to do all the iterations, number of iterations equal to the number of digits. So if you take average of these numbers, it will give us 37, which is exactly the centermost value of the data. So the second method is the binary search. I think binary search is more interesting and easy because in the binary search we are given with sorted data, and the first step, for example, we have to find 94 out of these data. Then the first step will always be we have to compare the desired value with the centermost value of the given data. Here the centermost value is 21. We will compare the 21 with 94. As we know that 24 is not equal to 94, but 94 is greater than 21, so we will ignore the values at the upper block and will only consider the values at the lower block. Again we'll do the same procedure. We'll again convert these the lower block into two further blocks and we'll compare the value 94 with the centermost value. 52 is not equal to 94, but 94 is greater than 52. Again we'll ignore the upper part and we'll consider the lower block. In the lower block we have three values. We'll again do the same procedure and we'll compare 94 with the 94 because 94 is the centermost value and 94 is equal to 94. This means that we have found our desired value. And how we find it? If we find it on our first, second, third iteration, we will have to go through the 3 iterations to find our digit, our value, which is 94. The third example is again related to this thing. For example, if we have a population of 7 billion and we want to find a person from the population, we'll how we can find that 7 billion when we multiply 1000 with 1000, it's 1 with the 6 zeros, which is actually equal to the 1 million. It will be equal to 2 raised to power 10 into 2 raised to power 10, and when we again multiply it with 1000, it will be 1 million, which is equal to 2 raised to power 30. But 1 million is equals to 2 raised to power 30, but we are given with 7 billions, and 7 is approximately equals to 8, and 8 is equals to 2 raised to power 3. When we multiply 2 3 times, it gives us 8. So we can consider 7 as 8. Then 8 billion will be equal to 2 raised to power 3 from the 8 and 2 raised to power 30 from this part. So we'll get 2 raised to power 33. So these 33 tells us the number of iterations. This means that we will have to go through 33 iterations to find a person from a population of 7 billion. So this is the end of our lecture. Thank you so much for watching.